Is your engine stalling or even having rough idle? The culprit may be the MAF sensor. In this video, we are going to be talking about how the MAF sensor operates, and then we shall go ahead and carry out diagnosis on the sensor. The MAF sensor is usually located between the air filter and the throttle body. So let's go ahead and describe how the MAF sensor operates. Then we shall come back and carry out diagnosis on the sensor. Before we can go ahead to carry out diagnosis on the MAF sensor, let's gain some bit of understanding about its operation. Now, the MAF sensor comes in different types, and one of them is the hot wire MAF sensor, and this consists of a platinum wire. Also have the hot film. This consists of a resistor plate. Also have the vane meter. This consists of a mechanical flap. We also have the vortex. Employs sound waves. It may also employ light. But in our discussion today, we shall focus on the hot wire because it's the one which is most common. And let's dive right into it and we see how it operates. Let's go ahead and explain how the MAF sensor operates. So this is our hot wire. So what happens, this wire is kept at a constant temperature, say about 100 degrees Celsius above ambient temperature. So whenever we have air, cold air blowing over the hot wire, its temperature will reduce, say to about 80 degrees Celsius. Now these are just used for illustration purposes. So what happens is, whenever the temperature decreases as a result of this air blowing over the hot wire, the ECU will have to increase the temperature of this wire. And how is that achieved? Now what happens here, remember this is made up of platinum, and platinum is a positive temperature coefficient. In other words, its resistance increases with increasing temperature, and its resistance decreases with decrease in temperature. So if we employ Ohm's law here, we have V is equal to IR. So I is V over R. When cold air blows over this hot wire, its temperature is going to reduce. As the temperature reduces, it means the resistance will also decrease. So we are saying that the temperature is going to reduce, and as a result, the resistance is also going to reduce. So if this resistance decreases, what happens? If we are to keep this value constant, the current supplied must increase in order to restore the original temperature or that constant temperature. So the amount of current that is required to bring back the temperature of this hot wire to its initial value is what is computed to its equivalent in either voltage or frequency. Now, if it is converted to voltage, this will give rise to an analog signal, and if it's converted to frequency, it will result to a digital signal. Now, the MAF sensor may give either an analog or digital signal, and the way we test for this is totally different, and the tools that we use are also different, because if you are to carry out diagnosis on a digital MAF, the best equipment used would be an oscilloscope, and we shall see that later on. Now let's go ahead and explain the wires that are usually found on the MAF sensor. Now the MAF sensor mainly has 3 wires. One of them is the power supply, another one is the ground, another one is the signal wire. In case you find the MAF sensor having 5 wires, the other 2 are usually for the intake air temperature sensor. Sometimes they are combined together. So if you check your MAF sensor and find that you have 5 wires, 2 are for the intake air temperature sensor and 3 are for the MAF sensor. So it's always advised to check your wiring diagram to see which color codes correspond to the MAF sensor. Now that we have established how the MAF sensor operates, let's go ahead and explain how this signal that is obtained from the MAF sensor is used by the PCM or the ECM. So we have our MAF sensor here, and we have this is our signal wire that is connected to either the ECM or PCM. Now what's the difference between these two? Whenever you find a car having PCM, this is powertrain control module. Now the PCM is a combination of the engine control module, which is ECM, and the TCM. So it's a combination of the engine control module and the transmission control module. So you can't find a car having ECM and PCM at the same time. It will either have ECM and TCM or PCM. Okay, now this data that is obtained from the MAF sensor, it is utilized by the PCM to calculate the mass that is flowing, the mass of air that is flowing past that film in a given time period. And this is what we obtain as grams per second. When you check your scan tool and you obtain the PID for the mass airflow sensor. The units will always be grams per second to indicate the rate of flow of air. Now this is used by the PCM or ECM to calculate the fuel that is to be delivered to maintain the stoichiometric ratio, which is 14.7 to 1, and this is for gasoline engines, so you can call them petrol engines. So this data is used in fuel injection. Remember, we don't want the engine to either run rich or lean, so it has to be at stoichiometric. In other words, for any given amount of air that is entering, it must be compensated by an equal volume of fuel in order for it to burn completely. And this plays an important role when it comes to emissions control. The same data is used in transmission control systems for easy transitions of gears, especially when it comes to automatic cars. Now that we have gained some bit of understanding about how the MAF sensor operates, let's go ahead and see how we can carry out diagnosis in case we have faults or codes reporting the MAF sensor.